viewers, welcome to Usman Chayin Physics Maths class. In our tutorial today, I shall provide a solution to the problem before us. And if you are watching this very video for the first time, I encourage you to watch till the last minute because I will going to share a very important trick. So let's get into it. A galvanometer has a resistance of 5 ohms by using a shunt wire of resistance 0.05 ohms. The galvanometer could be converted to an ammeter capable of reading 2 ampere. What is the current through the galvanometer? Now, the whole of this very question, we can translate it into a diagrammatic format. We can convert all this into diagram, and that will going to make our work very, very easier. So let's look at it. Yes, this is just exactly like this, okay? So now they are asking us to look for the current that goes through the galvanometer. It's very simple. It means that this is the total current that is coming through or entering the circuit. So we are going to have another current here. This current is the one that will go through this galvanometer. And of course, this is a parallel arrangement. So we're going to have another current that will go through or run through the shunt, and that should be IS. Okay, so if that is true, I want you to remember that to find the total current in this very circuit, we can say 2 ampere will be equal to I of galvanometer plus I of shunt. That is to get the total current in this very circuit. What of the voltage? To get the what? The voltage in this very circuit. Remember that this is the parallel arrangement. So the voltage that runs through the galvanometer must be equal to the voltage that runs through the shunt. So we can say V of G must be equal to V of shunt. And if that is true, we can just V from Ohm's law, we know that V is equal to IR. So we have I, this time is I of galvanometer, and then R of the galvanometer, small r, and equality sign. Then V of shunt, it is going to be I of the shunt multiplied by R, which is capital R, R of the what? The shunt. But our question, we are required to calculate the current that runs through the galvanometer, that is I of G. But what then is our I of S? We fall back to this first equation and we'll make I of S the subject of the formula. Now, from this equation 1, if you want to make I of S the subject of the formula, we just have I of S will now be equal to 2 minus I of G. So we'll substitute it back to this very equation so that we'll have I of G times the R is 5 equal to I of S. Instead of writing I of S, you write 2 minus I of G, then multiply by R is 0.05. We divide through by 0.05, 0.05. 0.05 will cancel out. Then 5 divide 0.05. Of course, we'll just have this. We're going to have 100. 5 divided by 0.05, we have 100. So we're going to have 100 I of G will now be equal to 2 minus I of G. So from here, we can just collect like terms. This I of G will cross to the other side, and this negative sign will turn to plus. So we have 100 I of G plus I of G equal to. Now, 100 I of G plus I of G we're going to give us 101 I of G. So we have 101 I of G equal to, and we divide through by 101, 101, 101. This will cancel this. Our I of G will be 2 divided 101 is 0.0198. Okay, so this is our I of G ampere, but our answer isn't milliampere, so multiply it by 1000. So we have I of G will be equal to 0.0198 times 1000. Now when you multiply it by 1000, you have I of G will be equal to 19.8 milliampere. If you take it to a whole number, it will now be 20 milliampere. So if you check the option very well there, you'll find out that the option C is the correct option. But then why are we going through all this trouble when we have a simple trick or a simple formula to follow and get our answer? Next time, if you are solving this type of problem, instead of going through all these traces, just use this. I of G will be equal to IR all over capital R plus small r. And when you use this, you're going to get the same answer, where I is just the current 2 ampere, then R is this 0.05, then small r is 5. Next time, use this very formula.